Hello all, this video is on industrial MODBUS RS485 slave RTU device manufactured by NSK Electronics Bangalore. It has got 8 relay outputs. This is to test write coils from PLC and 8 digital inputs to the right hand side. 8 digital inputs. This is to test read discrete inputs. And to the top we have 4 analog inputs. This is to test read input registers from any master PLC. And it has got RS485 as well as RS232. We'll be using RS485 media. MODBUS is protocol and RS485 is physical electrical standard we'll be using. It requires 12 volt 2 ampere power source. It has got protection diodes and regulators and master reset switch on board. This is built on PIC microcontroller IC. At the back side you can see the DIN rail mount, plastic DIN rail mount, so that it is suitable for any industrial application, and it has got LEDs for relay outputs as well as digital inputs. Now provide the power source 12 volt 2 ampere. The LCD display appears. It says MODBUS RTU SLAVE and ID is 1. And baud rate is 9600 and 8N1, that is 8 data bits, no parity and 1 stop bit. This you cannot change. And we require RS485 to USB device like this. This is also by NSK Electronics. This is the best one available in the market. It has got A and B pins. There is also Chinese clone cheaper ones. This is not much reliable, but you can use any one. At A and B terminals you can connect this RS485 A to A and B to B. We have used blue wire for B and yellow wire for A. Generally twisted pair wires up to 1 kilometer is supported by RS485. The other end of the module is connected to PC and a port is allotted to this module. To the right hand side of the module we have got 8 digital inputs, RB0 to RB7. This is to test read discrete inputs from any PLC. At the bottom we have got 8 relays. This is to test write coils from any PLC. This is RD0 to RD7. To the top we have got 4 analog inputs, AN0 to AN3. This is to test read input registers. First let us test read input register using a potentiometer. This potentiometer has got 3 legs. The top one let us connect to plus 12 volt. The bottom one let us connect to ground. The center pin is the arm, which is the variable potent pot. The center pin let us connect to AN0. That is the first analog input, AN0 of the RTU device. Let us connect. So by varying this potentiometer, this 12 volt this AN0 will vary from 0 to 12 volt. So you will get 0 to 1023 digital value, as the PIC IC we are using has got 10 bit resolution. 2 power 10 is 1023. For digital inputs let us use simple switches like this. This has got let us use the 2 pins of the 2 switches like this. One end of switch is connected to 12 volt and the other end is connected to RB0, and the same way another switch is connected to RB4. Now let us switch on the power to the module, RTU module. It says MODBUS RTU and slave ID is 1, and it has got a reset switch also for master clear. On the left side 3 micro switches are not yet configured. Now let us test using a master. A master simulator is required. MODBUS POL is an excellent master simulator, but it is not free. It has got 30 days limitation and then 10 minutes connectivity time limitation. And another master is QModMaster. This is a freeware. The QModMaster is a freeware open source. It is built on Qt application. This is also equally good. Let us test both the softwares. First go to the MODBUS POL, MODBUS Tools website, download the MODBUS POL. Mine is 64-bit PC, so I am downloading 64-bit version of MODBUS POL. There is also a MODBUS slave, but we require MODBUS POL, which is master. Install it and then open the MODBUS POL. At the top you have got some tabs, connection, setup, and then functions. Click on connect. It will ask for the registration as it is not freeware. Click on register later and you will get the connection window. Here you have to select the port. First select serial port and then under serial settings select the COM port. The COM port allotted to the USB to RS485 converter we are using. Here it is allotted COM4. Select the port and the baud rate is 9600, which is the baud rate of the slave, and 8 and 1. This is 8 bits, no parity, and 1 stop bit. In the advanced mode you want to take any selections and then finally click on OK. Now from setup click on read write definition. Slave ID is 1, which is that of the RTU device, and from function drop down select 15, which is write multiple coils, and address mode is decimal, and starting address is 0, and quantity is 8 as we are going to control 8 relays. Quantity is 8 and scan rate is 1000 millisecond, and then apply. You will see 8 address locations opening on the window. Select the first location 0 and feed in 1. You can see the first relay RD0 switching on the RTU module. Same way select the second one and feed in 1. This boolean coils are related to boolean. It is called coils in PLC. So feed in 1 to all the locations from 0 to 7. You can see all the relays switching on in the RTU device. Now feed in 0 to all the address locations from 0 to 7. Feed in 0 one by one. You can see in real time the relays are being switched off. So this is write coils, testing of write coils. Now select the function, another function write single coil, which is 05. You have to feed in only, quantity should be only 1, as the write single coil supports only one address location. Quantity is 1 and address we have selected 0, so only one address location opens. Feed in 1 to that address location, the first relay will operate. Same way from the setup, go to the function 04, which is read input registers. This is for selecting analog in. So quantity is 4. You will get 4 address locations. We are connected on potentiometer at AN0. Vary the potentiometer value. You can see at the address location 0, the value varies from 0 to 1023. As the it is 10-bit resolution PIC IC we have used. 2 power 10 is 1023. So value changes from 0 to 1023. This is analog in and it varies in real time. Next we'll select the function 02, which is read discrete inputs. This is to select check the switch inputs, and number of quantity we have selected 8, so 8 address locations open. We have 2 switches connected to the RTU device, one at RB0 and another one at RB4. Switch on and off the RB0 and RB4. Accordingly you can see the changes 1 and 0 in the MODBUS POL at the location 0 and the location 4. So we have tested relays and then digital input and then analog input. Next we will test the QModMaster software, which is freeware. This is open source. Download the QModMaster. The link is given in the description below. This is based on Qt application. No installation is required. Just double click the application and the window opens. From there you go to options and then MODBUS RTU. Here you have to do the settings. Serial input port you have to allot, and that baud rate 9600, 8 and 1. And from options settings you have to do the setting. There is some timeout you have to give. From 10 to 100 you can give, and the base address is 0. Endian, big endian, let us select and then click on OK. The base address is very important. Select 0 and the start address is 0 and MODBUS mode is RTU. From function code select the write multiple coils, that is 0x0f, which is nothing but 015. Note that under settings the base address is 0 and also the start address we have selected as 0. The number of coils is 8, so 8 address locations open. You can change the address locations, you can change from 0 to 1, but in real time it will not be effective on the RTU slave. You have to click on commands read write, then only it will be effective. We have selected 4 relays on condition, so the RB0 to RB3 4 relays are switching on. Now let us change the RB0 to 0 and RB2 to 0. Now click on commands read write. This will take effect on the device, slave device. So only after clicking read write button it will be effective. It is not in real time as in MODBUS POL. To switch on all the relays, feed in 1 to all the coils, and then from commands click on read write. You can see all the relays being on. To switch off the relays, feed in 0 to all the coils. Now note the location 7, RB7, still the cursor is clicking. Now click on commands read write. You can see only 6 relays off. The last relay is still on, as the cursor is still blinking at RB7. You have to come out of that cursor and then now click read write. The relay will be off. So this is also another point to note down. Next, select the right single coil to select, that is to operate only one relays, and the address we have selected as 0. Number of coils is 1, and clear feed in 1, and from commands click on read write. You can see the relay RB0 is on, as we have selected the address as 0, only the RB0 is switching on. Feeding in 0 and clicking on commands read write, the relay will be off. Same way you can select address location, suppose 4, it will switch on the 5th relay. If you select the wrong address, suppose the address you are selecting as 8, it will give error, that is read data error you will get. Only from 0 to 7 the slave has been configured, so only 8 number of coils allowed. If you select it as a digital 8, decimal 8, it will give error. So to switch on the 8th relay, select 7 and then commands read write, the 7th relay will be on. This is right single coil. Next, let us select the read discrete input, and then the number of inputs as 8. We have to select the check the switch inputs. So select number of inputs as 8. So 8 address locations will be open. We have 2 switches at RB0 and RB4. You change the switch positions, it instantly you will not get the result. From commands you have to click on read write, then only you will get the result. So unlike MODBUS POL, it is not real time. Only after clicking read write command you will get the result. In MODBUS POL software we get the result instantly, but in QModMaster only after clicking commands read write we get the result. Finally, we will check the read input registers, which is analog in testing. Select the read input register, that is 0x04, and the number of registers is 4, as we have got 4 analog inputs in our RTU. Number of registers is 4, and then click OK. We get 4 address locations, and from RTU device you change the potentiometer, you get the here you have to select a data format as decimal. It is in bin previously, selected as decimal. Now clicking on commands read write, you get the value of the potentiometer. The value is not instant, only after first you change the potentiometer value and then click on commands read write, you get the result. So the result is not instant, only after clicking the command you get the result. Thank you for watching.